In this video, we'll answer the question whether PCl3 is polar or nonpolar. This is phosphorous trichloride. So we have the structure here of PCl3, and this helps us understand whether it's going to be polar or nonpolar. What we're interested in are these bonds here. These are pairs of electrons shared between the phosphorus and the chlorine atoms. So here's our chlorine, 3.16, phosphorus, 2.19. Because we have this difference between these two, we expect the electrons in this bond here will be spending more time around the more electronegative element, which is chlorine. Because of that reason, this bond right here, it's a polar bond. But we need to really look at the molecular geometry to figure out overall if this is a polar or nonpolar molecule. Let's do that. So the purple, that represents the phosphorus atom, that central phosphorus atom. We have 3 chlorine atoms, 1, 2, and 3. They've spread out as far away from each other as they can, and then we're going to add that lone pair. The lone pair pushes everything down. So at this point, we have these chlorine atoms here on the bottom. They're more electronegative. The electrons are around them more, so this side of the molecule is more negative. Up here we have the phosphorus. That's less electronegative. It'll be a little more positive. So we have our poles, we have a polar molecule. Let's go back to our Lewis structure here. So to recap, because we have this electronegativity difference between the phosphorus and the chlorine here, that means that these bonds will be polar. And because it's an asymmetrical molecule, the chlorines are down here on the bottom, we'll have a polar molecule. Note that the bond angle here is going to be less than the kind of general expected bond angle of 109.5 because the lone pairs, they push down a little bit more. We end up with these chlorine atoms closer together, about 100 degrees between them. This is Dr. V, answering the question whether PCl3 is polar or nonpolar. It is a polar molecule. Thanks for watching.